So in this lab, what we're going to do is to look at some vulnerability analysis and some basic penetration testing. So this is the setup that we have. We have our firewall with our LAN, a DMZ, and then our WAN connection. So what we'll try and do is that we have servers running both in the DMZ and in the private network, and we'll use vulnerability analysis tools to be able to discover services and so on between both. So the network we'll be using is 192.168x.7, and then on the other network it's y.7. So the one we're going to set up is this one here. Okay, so we're going to use 99 for the LAN and 100 for the DMZ. The other connection should be DHCP. Okay, so let's start up our instances. So we'll just open up our pfSense just to make sure that everything's been set up okay. And we'll have a look at our Ubuntu image. And also our Windows one. Okay, so there we are. So they're just starting up now. Just get logged in. So this is our Ubuntu one. And we'll just get logged into our Windows one. Okay, so there we are. Right, so there's our IP addresses that we've set up for our firewall. So we can see 192.168.99.254 is the default gateway for our Ubuntu image here. And then for our Windows one, 192.168.100.254. So let's start to see what the configuration is that we have, just to make sure that we have connectivity. Okay, so that's working fine. So we'll ping the gateway, and that's working okay. Now let's ping the Ubuntu machine, and that's working okay. So again, we'll do the same. We'll have a look at the setup here. And let's ping ourselves. Let's ping the gateway. And let's ping through the firewall. Okay, so everything's working perfectly. So we can run Warshark if we want, or TCP dump. To be able to show us any traffic that we have. Okay, so just to show over here, if we now ping again, we should hopefully see the ping coming through. So there it's there. There's the ICMP echo request from them. Okay, so we have connectivity. So let's have a quick look at the settings that we have on the firewall, just to make sure that we can actually test from the LAN to the DMZ and vice versa. Okay, so if you look at the LAN, we'll find by default it will allow anything from the LAN network on IPv4 on any port access to anything else. Okay, so this is the rule that will allow any traffic to go out of the LAN network. It remembers it and allows it back in. And then for a DMZ, what I've got is I've allowed 443, UDP 53 and port 80, and also allow ICMP to any destination. So now what I'll do is I'll add in a rule that will allow us to go punch through the firewall between the DMZ and the LAN network. Okay, so let's find, so let's just go for any here. Source from the DMZ to the LAN. There we are. Okay, so that allows any traffic from the DMZ on any port to the LAN network. So hopefully now we'll be able to use our vulnerability tools between the two. Okay, so the first thing we'll do is we'll discover the services that are running on each machine, and we normally do that with netstat -a. So on our Windows machine we look at the listening ports. So the services that are listening, these are server listening ports. There's FTP, SSH, Telnet, SMTP, domain, and so on. And now let's do the same for our Linux machine. And this shows us our listening ports. And we can see here we have FTP, SSH, Telnet, there's web, and SMTP. Okay, so those are the server ports that the Linux machine is actually running on. So what we'll do is that we'll try the web service from each just to see that we have that connectivity at a TCP layer. So this is 192.168 and then it's 99.7. Perfect. Okay, and then we'll do the same over here. 192.168 100.7. Okay, so we have complete connectivity between at a TCP and application layer for port 80, and so that's working. Okay. So the other way that we test for services is we can use the command line. So the command line is the method that we would use to be able to see if a service was alive, and we typically use telnet on a certain port. So in this case we're going to telnet into our Windows machine on port 80. Okay, so we do get. There we go. And it gives us, so HTTP is a stateless protocol. We send a command just like the browser would, and it responds back with a web page. Okay, so that's just like the page that we saw there. So again, we'll try this on the other side. We're on telnet 192.168, and then it's 99.7 on port 80. We get a blank screen, so don't worry, get / and there is the page. Okay, so that's the equivalent of the page. This is a sample, this is a sample page, and so on. Okay, and this way we can actually test the services through the command line. Now what we'll do is that we'll just try the FTP service just to see if it's working. So we're going from Ubuntu to Windows. Okay, and then we type in user, API, password. These are the FTP commands. And unfortunately can't log in there. So we just quit. Okay, so the FTP service is working perfectly, and then we'll do the same over here. Sorry, we're going to the Windows machine, so let's try that again with administrator. So user, administrator, password, API, and there we go. Okay, so you can look at the commands here. That's the commands that are supported, and then we just quit. So over here, what we'll do is we'll do the same again. User, API, and we have an encrypted session on there for that, but that shows us that the service is connecting. So now over here, if we do our netstat again, we'll actually see that one of the services that's running is VNC, which is actually the remote desktop service. So let's see if we can connect to it. One 192.168 99.7. Okay, so you can see what happens over here. This is the remote desktop message, so we'll allow that. And there we go. Okay, so the remote desktop connection allows us a method to be able to remotely log into a machine and then access the services on it. So let's just disconnect that. And so the next service that we're going to use is for email. So when we looked over here, when we looked at our services, one of the services that's running is SMTP, which is an email service. So what we'll do is we'll log in to SMTP just to see what we get. 7.25. Okay, so there's the message that the SMP service gives us. Then we can do help to show the commands that we can actually use. So one of the commands is hello. And then we can actually type in the email message. And then we type in data. We need the receipt too. Now we can put our data. So this is the message from Bill to. You can put the date in there, and then the subject. These are all standard HTTP, SMTP, and command fields. Type in the message, then we do dot, and then cache return, and then we can quit. What we can do over here is to go and actually have a look at the queue. So normally our servers on our web server, email server, FTP server are stored in the inet pub. So if we have a look in the mail route here, and then we have a look in the queue folder, we should be able to see that our email is actually stored there. So it's put in the queue until it can actually be sent. Okay, so this is what our email message actually looks like. There's a whole lot of headers that go onto the email, and then this is the message here. So when it's received, all this is stripped off, and all we see is this part here. Right, and this next part of the lab, what we'll do is that we'll run a host scan using Nmap. So we'll run it from the Linux machine. And if we need to have a look at the options, we just put the question mark in. So the first thing we'll do is to run a scan of the WAN network. Okay, so /24 means the first 3 digits are significant here, 10, 200, 0, and then all the other hosts will be scanned. Okay, so this can take a while to run, but we can see 8, 16, 54, 101 and so on are online. So 11 hosts are up. Same again, you can do it over here with Nmap. 2, 0, 0. And while that's doing that, so there we go. So we should get the same result coming back. So the next thing we'll do is we'll go from the LAN and we'll scan into our DMZ to see if we can actually pick up the host server which is online. So it's there. So we should hopefully just see two hosts there. One is the gateway and the other one is the our host here. We'll do the same again over here, just to make sure that we can see the other side and it's actually getting through. So what we're looking for is 99.0. While that's doing that, we'll run Warshark, just so that we can actually have a look to see the traces of traffic that we get. Okay, so there's what we see. There's the connection into the network there. We see lots of scans coming through for each of the hosts to see if any of them are actually alive. So what we should see is that occasionally we will get a reply. So what happens over here is that we send it a ping, and then the ping comes into the other network and it appears as an ARP into that network. So here we can see this is the gateway trying to find out if the nodes are online that are being scanned. If they are, there's the reply back, and then there's a ping reply. So over here it's a ping request that goes out, it appears as an ARP, and then we get a ping reply. So for the hosts that are actually online, there's the reply that actually comes back. Okay, so all the other traffic is the gateway trying to discover that host on the network. But what comes out from here is a ping. What appears here is an ARP, and then an ICMP packet. Okay, so for this one we get ICMP. What we'll actually find if we run it again on the local network, so if we are local, then what we should see is an ARP scan. So if nmap is local, it will try to be as quiet as possible, so it will actually do an ARP scan of the network. Okay, so you can see here, then this is the host that's scanning, and it's asking for all of the network. And occasionally it will get a reply back, which means that the host is online. Probably at 254 it will get a reply from the gateway. There it is. Okay, so nmap does an ARP scan locally, but if it's across different networks it will do ping sweep. So the next thing we'll do is we'll try to pinpoint the operating system that's actually running on each machine. So from here we'll try to do an operating system scan. And we'll do the same over here. And so what this does is it sends out some packets and sees how the operating system responds back to them, and in that way it can try and determine what the operating system actually is. Okay, so here we go. So for the first one, it's found the services that are running. But it's not actually been able to find the operating system from there. And so let's try it from the other side. Okay, so while it does that, let's start looking at the actual fingerprinting of the application services. Okay, so we can try and look at the actual version of the service that we're actually running. So we want 100.7. Okay, so that shows us the services that are actually running on there. So this one has managed to say it's OpenBSD for that one. Okay, and then we can go and pinpoint a certain port and see if we can find the version from the banner grab. Okay, so this is going to go and look at the, so you can see here, this is a Microsoft IIS server, operating system Windows. So we'll do the same over here, nmap, and then just let's change the font size. So nmap 192.168.99.7. Port 80. Okay, so we can see Apache, HTTP, and then there's the Ubuntu and so on. So the -SV on port 80 has picked up the actual version of the server. So we can do the same again for other types of services. In this case, that's the FTP one, and there's 53. 22, and so on. So the next thing we'll do is we'll grab the banner from the service just to see what it actually shows us. So we'll run telnet. And now what we'll do is we'll send in another command, which is options / http 1.0, and see what it returns back. Okay, so we can see here it's returning back the server type, and we can see it's ASP.NET and so on. So let's do the same over here, just to see what our Ubuntu web server, our Apache web server responds back with. 192.168, then it's 99.7. Oops. Port 80. Options / http / 1.0. And we can see here it's returning back Apache, Ubuntu, and so on. Okay, so in this way we can actually examine some of the information that comes back. Okay, so there are other commands that we can use. We can get just the header of the information, the reply that comes back from HTTP, and there it is there. So that's showing us information such as the default web page, when it was last modified, and so on. And we can obviously use the get as we did before. So let's have a look at hping. So hping allows us to be able to craft network packets. So what we'll do is we'll start a TCP dump and then have a look to see what our hping looks like. So it may go through the firewall or not. The firewall may block hping, so we'll just analyze it from this side. And so if we run hping, okay, so let's let it run. And what we see is the connections. We're seeing a few pings coming through there, some ARPs, but we should see the connections. There we are there. Okay, so what hping does is it makes a connection between the local machine and the other machine on a certain port number. So this is connecting to port 0. So if we want to connect to port 80 specifically, then we can send that in like that. And there it is there. Okay, so we can see that's making a connection from the local machine onto port 80, which is the web port. There are no flags set. Okay, so if we want to set a flag, we can have a look at the manual. So if we do the -s, that will send in a SYN flag. Okay, so now you can see that it's actually working, and the reason for that was that the firewall was actually blocking our access because the flags were wrong. The firewall was looking for a SYN first. So actually if we run Warshark over here, we should hopefully see a SYN flood coming through. And there it is. Okay, so we get continual accesses on port 80. Okay, so this is known as a SYN flood attack. So let's just see if we can get the ACK to go through. And now you can see that's not actually working. It's trying, but the firewall is actually blocking it. Okay, so only the SYN is actually getting through there. And we can do the same on the other side, and we can craft our packets like that. Okay, so we can use hping to be able to craft some vulnerabilities. So in this case we can have a count of one packet on port 80. And we'll send that to the Windows machine and see what we get. Okay, so this is the response here, and you can see it hasn't actually gone through. So now let's look at how we can use Hydra to be able to assess the vulnerability of usernames and passwords. So what we'll do is we'll set up a user. Okay, so we'll just change the password. Okay, so what we have is that what we'll use is we can use Hydra to be able to assess the usernames and passwords. So in this case we have a user file and a password file, and then we're going to use Hydra to be able to try each of these usernames and passwords. So we'll just start Warshark over here just to see the basic traces of what it looks like. Just watch that there's a little window at the back there. Okay, so let's go. And what we should see over here is a great deal of traffic related to Telnet. There we go. And what's really happening there is that the Hydra is trying lots of different usernames and passwords to be able to see if it can find one. So it's found one there, login and Napier 123. Okay, so the next thing we're going to do is to be able to run a necess scan. And the first thing we need to do is to make sure that the necess scanner is actually running. And that is there. So we'll just start that service. And then we'll run necess. Just log in. So now what we're going to do is we're going to scan the Linux machine. So the first thing that we actually do is to create a policy. So we just go for some basic port scanning. Okay, new policy. And we can go for various preferences. We can go for plugins. So what I'll do is I'll just select one or two of these. And I'll just go for port scanning initially. Okay, so that's me created the policy. It's just going to do a very basic port scan for it. And so over here we can start up our TCP dump, and then we can go to our scans. Okay, new scan, and then we'll run from here. And we're going to add our target. And then over here, if we had Warshark running, we'd see lots of traffic related to it. But we'll just let it run. We can have a look to see what it said so far. And because we're just doing a basic network scan, we can actually see it starting to pick up the ports that are running on the server. We can click on them at any time and actually have a look to see the details of the scan. It also gives us the CVE number and then some basic details of it. So now let's look at how we can use snort to be able to pick up things on the network. Okay, so we'll just go into here, and so what we have is a rules file. So this is a rule for later, but what we'll do is we'll set up a very basic rule, which is to be able to alert for a ping from any host to any port to any other host, and we'll have a basic message ICMP ping, and we need to apply a rule number onto each one. Okay, so this rule will basically just pick up a ping. So with snort, what we have is we can define an interface that we listen on with -i. -c gives us a rules file. So what we'll do is we'll create a log folder. And then we're going to listen on, we have only one interface, so interface 1. That's a rules file. We're going to log to log new. And we're going to use ASCII format for our logs. Okay, so that's running. So what we'll do is we'll just ping that machine 1, 2, 3, 4 times. Control C, and we see here we have 8 alerts, and the reason we have 8 alerts is because it is detected both if we look in alert.ids, it has detected both the request and the response. A type 8 is an echo, and a type 0 is a reply, so that's why it's picking up to them. Okay, so that worked fine. So the next thing we'll do is we can enable a preprocessor to detect things like a sweep on the network of ports, or also on the ports on the machine. So this is a preprocessor using the FS port scan, and it's picking up IP, TCP, ICMP, and it's got high sensitivity for the scan, so it will pick up Nmap, and it's going to put it in port scan. Okay, so let's run that again, and let's see if we can find the one that we previously ran. Okay, so now what we'll do is we'll run an Nmap. This is scanning the ports on the machine, and hopefully it should have picked it up and put it into a file called port scan. And there it's there. Okay, so there's certainly something in there. And there it is there. Okay, so it's actually detected our machine has done a port scan. It's detected the number of ports that it's scanned, and so on. So we can do the same again for a different type of Nmap and see if that works. Okay, so that's been an introduction to vulnerability testing.